I need to shave. Alright, okay. Alright, okay. Alright, okay. Firstly, have a sip of coffee. Keeping track of name. Oops. Me zoom in a lot. Yeah. There is something I've been thinking about. Well, not just thinking. I want to do something about it too. Now that maybe halfway, maybe. I want like a J. Where's run? Yeah. Not sure. I decided to do. I want like a visual representation of the stack for one, and stack and instructions. Yeah, same as above. Fucking anal bitch. Okay, yeah. So I want a visual representation of the stack and the instructions. The reason is, I think when I was fixing the if statements, I realized don't really know. It's quite hard to know what's going on as it is right now. So I want a way. So I want to. Okay, what do I want to know? What instructions are getting executed? What elements? Not elements. What variable? No variable. It's a variable. What constant is the instruction executing on? As in to see. Yeah, so if there's an instruction that's executing right now, I should be able to see pause, play. Yeah, so I should be able to see what it's executing on. Hey Isabella. Yo. Nothing much, just doing some programming. play, maybe even control rate of execution. Skip ahead. Maybe. Oh, sorry. What's up? Nothing much really. I'm working on this compiler, and I realized I don't know what's really going on when the program is running. So I want like a visual aid to be able to see what's really going on. But I'm not sure how to build it yet. Actually, yeah, if I can control the rate of execution. What am I looking up? Guess the simplest way to see what's in the stack would be, I mean, some form of ASCII. Be nice if I could just use the library. Yeah, actually, something like this. This could work. Yeah, same guy. Or I could just do it myself. I let it sit there for a bit. No, because I'm not exactly sure what to do. Or how to do it for that matter. But I do want to do it. Sounds fun. Okay. Okay. Is there gonna be a lot of reading today? Not too much. Until now, we reference values in a monkey by using Boolean and integer literals. That's going to change. We can implement bindings by adding support for let statements and identifier expressions. At the end, we'll be able to bind any value to any name and then have the name resolved to the value. How would this work? Interesting. Here's a short refresher of what let statements in Monkey look like. Yep, they're expressions. It's very similar to if expressions, really. We have the name, we've got the past expression, we make the instructions. So the only thing to decide is where to store these variables and when to remove them. Keyword followed by an identifier. Blah 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 blah. Yep. Yep, okay. This is the test case. Okay. Just not sure about the mechanism of storing the variable. Usually it's done in the stack. I don't know how it works with variables. The plan. Let me get my slightly larger glasses. Exactly. Off the top of my head, I'd say it's some sort of map. Oh, but then there's scope as well. Interesting. Yeah, actually, not sure at all. No idea. Obviously, we need to compile let statements and identifier expressions to bytecode instructions and support these instructions in the VM. That much is clear. Yep. Also, there's no debate about how many new opcodes we need. How many do we need? When we come across I guess just one. Oh no, maybe two. One to save the variable and then one to retrieve it. So here it will be infix x and constant. Maybe, I'm guessing two. Okay, yep. But what do these instructions look like? What do they look like? Good question. I guess saving it is quite easy. Because it's just, you make, yeah, I think saving, it's fine. It's just one instruction. It's the retrieval bit. What would the instruction look like here? Interesting. Not sure about the second bit. The main task when implementing bindings is to have the identifiers correctly resolved to the values they were previously bound to. If you can pass around the identifiers when executing the code, like we did in our evaluator, that's not much of a challenge. Like we did it in our evaluator. Don't remember, because I didn't do it. You can, for example, use the identifiers as keys to a map which you store and retrieve values, but we can't. Yeah. That's what I was initially thought, but yeah, that won't work. We're now working with bytecode, and we can't just pass around identifiers in bytecode. Yep. I guess would be in an instruction to retrieve variable. The question is from where? Or, okay, actually it could be like pop. Wherever you use the instruction, the current value, sorry, wherever you use the variable, the current value of the variable will be pushed onto the stack. Yeah, I think we don't need another data type. And luckily, there are no constants. So that's something. How do we then represent the identifier in these instructions? And how do we reference the value that should be bound to the identifier? The answer to the second question consists of 2 words. So let's start with that one. The stack. Yep, that's what I was thinking too. Fucking genius. Yep, that's it. We don't need more than that. We don't need to explicitly reference the value we want to bind. We have a stack machine. We can just push the value onto the stack and tell the VM, now bind, yeah, exactly. Now bind the topmost stack element to this identifier. Yeah, because, I mean, it works with variables. Actually, it could work with constants too. You do the same thing, you just push the same values back on. And you just check. Yeah. Okay. Back to the first question. How do we represent identifiers in our bytecode when we can only use numbers as operands? How do we represent identifiers? Ooh, that is actually a problem there. Because, yeah, let's say I say let x equals 5 times 5, and then I say no, actually no. Well, what am I thinking? That's not a problem. The answer is hidden in the question itself. We'll use numbers to represent identifiers. Okay. But then there's a small problem. When you do x greater than 10, no, it'll be prefixed with a, not prefixed. It'll come after an opcode for a variable. Okay, I think I kind of get it now. While compiling this, we'll assign a new unique number to each identifier we come across. In case we've seen the identifier before, we'll reuse the previously assigned number Previously, how do we generate new number? We'll keep it simple and just use increasing number starting with 0. Yep, okay. We'll define, this is how it's done in other languages. This is just numbers. Crazy. We'll also define 2 new opcodes. We want to call them opset global and opget global. Why global? We then compile a let statement. We limit an opset instruction to create a binding, and when we compile an identifier, we limit an opget global. "16 bits for the operand" means we're limited to a maximum of that many. Yeah, exactly. Plenty. Three monkey let statements from above would then look like this in bytecode. Up constant. Right, yep. So opget would be followed by the name of the variable. Oh no, the identifier for the variable. Yep. Yeah. Okay. Okay. In the virtual machine, we'll use a slice to implement the creation and retrieval of global bindings. We'll call this slice our global store. And we'll use the operands of opset global and opget as indexes to it. Excuse me. Jeez Louise. When we execute an opset global instructions, we'll read in the operand, pop the topmost value of the stack and save it to the global store at the index encoded at the operand. Okay. I guess that should take care of scope. Maybe. I mean, I don't know why I'm thinking of scope at this point. To execute an opget global instruction, we'll use the operand to retrieve the value from the global store and push it onto the stack. That bit I don't get. When we execute an opset global instruction, we'll read in the operand Pop the topmost value of the stack and save it to the global store. Okay. Huh, okay. And we'll use the index, okay. Okay. So we need another slice. Well, compiling and the global store in the VM sounds doable. Yeah, it does actually. Okay, I think I kind of get what I need to do. Let's start off with this statement. And then this one. Okay. Hmm. Need I'll leave pop there because I remember the value now. Get. I think I know why it's called it global. Then what was the other one? Set. Then get set global. Then operand with b2. I would upset take as an argument the name of the variable, right? Yeah. Then okay, go to Ben Firestar. This would be get global. Would get and then variable name. Okay. So in both instances, it's going to be variable name. Global. give it index of 0. And then 0 and 0. Set to get, give it index, well, I guess should be the same. Now, excuse me, I gotta look at the st. Let statement, token name and value. Some excuse me. Okay. Token name and value. So I need to oops, wrong file. Don't need this anymore. Statement. Okay. I think we don't need the else anymore. Statement. Oh no, there's a return statement as well. And make set value. Oh no, I gotta add constant, set value, and then how do I keep track of the index? I guess not a big deal. Okay, so const value will be try self dot compile. What does it take? A node. ast dot node dot expression dot value ast name value is an expression. Okay, so const. No. Gotta make or emit constant with value. Expression prefix opcode op minus. There's integer here. Okay, so the up constant should already have been added. Okay. Operator and operand. Okay. Don't need this value actually. So that's that done. Excuse me. Now I gotta emit op code. Sorry, code dot code op set global, and then I need the index. To add index. Is that it? Seems too easy. I'm still not sure how retrieval works. AST identifier. Okay, there we go. Okay. So I need to keep track of index. Global index is 16 because that's as many as we can keep, I guess. Because that's the width of the operator. Sorry, that's the width of, yeah, all values are 16-bit wide. That makes sense in the compiler. But hang on, there's something I gotta check. Emit. Okay, take 64. Keep this the same. And this can't be -1. I guess 0 is fine. And to do self dot global index. What do you mean? Oh, sorry. Then self dot global index plus equals 1. Yes, that's it. Hang on, I'll be right back. Get some coffee. Okay. And then back. Okay. I mean, what could go wrong here, right? What if the variable's already defined? Hmm. Not sure. Excuse me. I would then have to like keep track of what variable name saves to which index. I'm sure I'll leave that for later. But now, expression, teacher, yep, here, dot identifier. Get global, but which one? Yeah. I guess I got to keep track of the identifiers. I mean, it does make sense. Compiler. I mean, that would solve two problems. It would also solve the problem of the duplicate. I want to see how Torsten's done it. Okay, of constant 0 offset. Yeah. Yep. Push the global bound to 1. I mean pop. Ah, fuck. Actually, I don't. I just no. That's stupid. What I was thinking was just get global and then global index, but variables are not going to be accessed in order, so that doesn't make sense at all. Okay, maybe I should check if that works. One thing at a time. This, paste it here. Pile, variable declarations. Why is it called let? Where does it come from? Oh, now I want to know. In programming languages, example Swift, and I think JavaScript too. When declaring variables, why is it called let? Okay. Ah, okay. Okay. That makes sense. Okay. Now I know. compile, let statements, input expected constants, and then expected instructions. Yep. Yeah, it can be numbers for now. At x equals 5. Expected constant is 5. Don't need that. Op constant, and then op set global. Operands should be 0, because that's the index. And then pop. No pop. There should be a pop eventually, because the stack needs to be cleared. Then get rid of the rest. Okay, take test source compiler. Okay, that makes sense. Try. I think it returns something as well. Yeah. Catch. Return compiler. Error out of memory. There is no pop. Why? Integer. That's weird. Pop. Pop. Oh, okay, because it's not an expression statement. Makes sense. I wonder. So that's it. Just I mean, that was compile variables. That was a bit anticlimactic. identifier. To get the global index, I need to save the index. Oh shit. There's another compiler error. Undeclared identifier. Okay, I think we need a second slice, or a third one at this point. Global variables, optional, yeah. Slice of const u8, and the index would be global index. Actually, then I don't need this. New here, global variables equals null. I can do where do I add constants? Constant add global variable takes variable name, which is a const u8, and returns the thing is, I still can't check if it's unique. I mean, if it's been declared before. Maybe I can. I can just check the slice if it exists. Return, yeah, and it'll return the index. Variables be an array list of slice const, yeah, slice of const u8. Variable variables. Self dot constants. Variables dot append slice. Yep. Variables dot append variable name. Global variables. What did I call it? Okay, so this would be, yeah, leave that to do. Compile, set global, try self dot add global variable. Dot name. Identifier dot value. I need the index. Index is equal to catch return compiler error dot out of memory. And this would be global index, and I can remove that. I think the test should still work. Okay. 199. Self dot global variables. Okay, yep. It's a slice of. Okay. Slice of constituate is just the string, basically. But it's immutable, obviously. Okay. Oh, now I need identifier. I think they should fix the duplication problem as well. Okay. global variable index identifier dot name const index equals, and then self dot emit I think there's something else I want to fix. Sorry, code dot opcode dot op get global, and then index. It's gonna need a bit of a refactor, but file error catch return compiler error dot out of memory. Return okay. But now that means self dot emit the fuck is wrong? Okay. Damn, this might be quite a few of them. There must be a better way to do it. mean, this can't be the most entertaining thing to watch. Fuck. Hang on, I think there's fucking too many of them. I think there's a better way. In Vim, how can I replace this with emit is actually okay. There's another way. How do you? Is it at? No. Q. Oh, okay, got it. Say QA. Try. Okay, I think that should work. There we go. Okay. Okay, I think that's everything. One 39. Oh yeah, this one. I need to define it. Actually, there was one more thing. Add global variable. Add constant. Compiler error. Okay, there's only one. That was easy. And add global would be the same. return compiler error dot out of memory. And the same here. I think I made a mistake. I do want to check. I think that's the only error. Allocator dot error. Yeah, there's only one error. Might as well just handle it myself. Yep, same. Okay. Didn't add global variable. Yeah, I gotta define that. Function get global variable index. Get global variable index. Text compiler and then variable name. Const u8. Compiler error or index. Okay. Okay. 0 or self dot global variables. Const variables is self dot global variable, and there was declared identifier. Set away. I can return an error. I think, I'm not sure. Here. Or because this is also an optional array. Oh no. Is it? No, it's an array of optional. I32. It's not the same. Okay, I think. Global variable. Compiler error dot undeclared identifier. Or global variables. If mem dot equal u8 v variable name comma v return I. Okay, does that work? No field name identifier dot name. $139. AST identifier the value. Get global. Okay, now I can add the test. set global index should be the same, and then okay, that works. Just to double check. Okay. Constant, is it? Yeah. Constant, add 0. And then this is the opcode for set. Also 0 is the operand. And this is get 0. Okay. Okay. Guess now all that's left to do is execute. Oh, there was actually one more thing. Yes. Redeclaration. Duplicate identifier. Can do it here. How can I check? Get global variable index. Variable name. And ask cloud. This statement should error if everything went correctly. How can I check if it did and continue execution? Fuck, why the fuck is it giving me in Zig? Oh, you can have an else here. Hmm. I don't know if this is correct. Errors. The problem is if I add a catch and then continue execution, I still need to check that it returned an index. Or I guess I could make this simpler. Then by 64. -1, and then just return yep, that works. And then here if index equal to -1, then compiler error dot undeclared variable. identifier. Okay. And do int cast index. Excuse me. And then, yep. Const index equal to if index not equal to -1, then compiler error dot duplicate identifier. Okay. $166 and cost. Okay. Right. And now compile variables. Okay, I think that's it for today. I'm continue. All this is done. Okay, I should have called it the symbol table. Okay, I might have to go back and edit a few things, like this symbol table, for instance. Yeah, okay. I might have jumped the gun a little bit. That's fine. I think I'll do this tomorrow. Okay, I think that's it for today. Thank you for hanging out, and I shall see you tomorrow. Have a good one. See ya.